There we go. Hello, folks. Time for some streaming. Ooh. Really got like a water drip situation going on with my water bottle as usual. Okay, so let me just dive right into this stuff. So first things first, I've got a couple bug reports that I'm going to track down right away. Because they're of the easy and fatal type. They're neither fatal hard nor easy easy non-fatal, right? I have a couple of easy fatals, so no reason not to. No excuses. So let's see, it should be right in here, but does not equal backwards. Otherwise, if it does not equal key back. Okay, so what's happening up here? String size. Okay, right. So this is me just being retarded. Yeah. My mic is kind of quiet. Alright. Well, we can't have any quiet mic nonsense going on. My mic's all the way up over here. What's going on over here? How does one do this junk? Hello, is it working? Here's the one that we're trying to use. It doesn't, the webcam's picking up better than this one for some reason. What's the deal? Okay, is this better? I think that's not gonna get any better. Yeah, Popcorn, I'm aware of the iSearch bug that I just tracked it down and fixed it just now. And let's see, is there anything else? I have a to-do list so that I don't have to remember these things. Oh, I moved that into the code file, that's right. Let's see. Open empty file bug, I feel like it's something I should track down today, so we're going to debug that situation too. Once we're done debugging a few things, I'll get to some other stuff. The rest of these bugs are all super non-fatal. That one's annoying. This one's like whatever. It's not that big a deal. Like I and one other person want this feature. Yeah, that's totally non-fatal. Non-fatal. This is fatal, but it's too specific, so it's too hard for me to do. So really, that should go under the hard bugs. To-do list. These are things which I should really deal with. Some of them are non-fatal even, but they're so hard that I'm ignoring them, which is always a good idea, I think. So to answer the question from earlier, by the way, FrantiChat, no, there is no jumped error built into 4coder or into 4coder custom. If you get if you're a power user, you get the handmade hero customizations, and these have a go-to error that totally works. So you can, if you get this code, or if you watch it on Handmade Hero, I think I told Casey that he could also put it in his Handmade Hero thing, because I want people who bought Handmade Hero to be able to get access to his error parsing code if they want. So, oh, Fucon says he can increment numbers in 4coder. That's awesome. It's good to know. It's good that you've got that under control. So, all right. So, let me see. Do do. Okay. So, I was dealing with this empty file bug. So I popped open my debugger. What is dismiss all? Okay, so now there's supposedly this bug where, and I believe them, I just haven't seen it, so I have to see it for my own self. I have to experience it my own. We're gonna create a new empty file.txt, and we're gonna try to open it. That doesn't work? That's correct. I mean, that's what it should do. Does anyone here remember what the empty file bug is supposed to be? Because it looks like I can just open empty files, so I'm not sure. Maybe it's if they're CPP files it doesn't work. Control I, Control O, that's no crashing. Are you on, Linux, maybe? Well, anyway, as I said, empty file.txt. Alright, Fucon, bye-bye. So it sounds like this empty file bug is a Windows 10 thing, and as I've said before, I'm not really debugging non-Windows 7 things yet, because there's too many random things, as we've already seen in the chat, where different operating systems of Windows just fail for random stupid reasons, and I'm not really in a position to deal with all of those yet. Okay, so what we're going to do here is put this into like a limbo state and say possibly a Win 10 issue. And so there we go. Alright, so Popcorn, what do you mean? What doesn't work on Windows 8? Alright, let me try this again one more time just to be sure. If I do Control I O, yeah, I don't see anything wrong with that. So I won't be able to debug that until I get test machines for all these other operating systems, or set up the VMs and get. I still need to get the licenses, the thing. Really. So I think that's the other thing I can do, of course, is I can try running the release build, which can always be different. So let me go over here to the current distribution. I'll try them both. Boop. Control I-O. Yeah, that's fine. Just super. control IO. And there's always the possibility that I've actually fixed the bug accidentally since then anyway. Okay, so doop doop doop. Ooh, pressing Control O crashes at anything on your end. That's interesting. So, Franti chat, I'll put it up. I should add this to like a thing. Let's see. Let's see. How do I do edit scene? Add text email editor at 4coder.net. I don't see text. Properties. Oh, here we go. Email editor at 4coder.net. That's too big. That's no good. Why is that so big? That's weird. It's supposed to be that big? Okay, so this is also scaling it, which is awesome. It's barely legible. What's the deal with that? It's really that blurry? What's the deal there? Opacity's all the way up. Use an outline maybe? I mean, that doesn't really make it less blurry, it just makes it a little bit like the blurriness is manageable. Maybe it's still just too big. Okay, so there you go. So if you have bugs, send them to the email that you should now see there. Well, I can't really make the font size bigger. It won't fit, will it? How does this even work? Properties 48. Okay. Yeah, look, now it's gigantic again. All right, here we go. Okay, that's too big. 24. Let's try this. A little smaller then. 20. Bloop. Do. There we go. So you have bugs, that's where they go. Alright. So that's pretty cool. Let me move this down a little bit. Position. No order. There we go. Control down. Okay. So there. If you want to give me details, tell me the exact directory you're opening in and give it to me as a string with all the characters in it. It could be a problem with the characters in the home directory. It could also be a problem with the length of the home directory. It could be all sorts of things. So I'm going to add a sort of debug log situation soon. In the meantime, if you have bugs, please send them there. Okay? All right. Now, let's get to the cool thing I want to do today. So I've got, let me see what we have here. I've got this old Lexer, right? And it's fine, it works correctly. But the problem is, and this is on the to-do list in this file, is it does not lex in chunks, and so I can't switch to a gap buffer as long as it requires the entire buffer to be contiguous. I could, stringify the entire buffer every time I want to lex, but that's not ideal. Plus, if I make it chunkable, that also makes it resumable. So that's the plan. Is we're going to revisit my old Lexer and we're going to start improving it. But to really get into that, what we're first going to want to do is let's see, experiment. What's inside of experiment right now? Yeah, what I want to do here is scrap my old experiment, build up a new one. So here I have the old Lexer. Or here I'm going to include 4cpp new Lexer.h. And what we're going to do is just say that everything in the new Lexer is going to be dropped into a namespace for now. New Lex. There we go. That way I can give them the same names, and then when I'm done, I'll just stop using the namespace. Yes. And then I need a 4cpp new Lexer.h. I'll pop over here and look at my Lexer. Alright, so things I want. First of all, I want to exactly copy everything out. Let's just do this the fast way. There we go, and pop it in over here. Am I getting like a frame rate issue now? Since when was there a frame rate issue? It might be because of OBS. And it feels a little not as smooth as it has been in the past today. Weird. And slightly concerning. But anyway, so there's the top. Now I want to decide if I want 4coder config. What is going on here? I'm pretty sure I just want to scrap all of this stuff. So, yeah, I don't really want to do all this. I was messing with this last time. I don't want any of that, so we're not going to take config. Alright. Which means that a lot of stuff isn't going to work, but that's fine. So we're going to use the same types and everything. So I think a smart thing to do would be to say, let's start by going over here and doing 4cpp Lexer types.h, right? 4cpp Lexer types.h. There we go. Top. And sorry if I bumped the mic. CPP Lexer types, and then what I want to do is everything that constitutes, well, first of all, I'm going to include at the top of this 4cpp Lexer types, and then I'm going to take all of these things that are just types and drop them in over here, because I don't really want to change much of these, I don't think. There it is. Okay. Looks like that might be the end of the enums and structs. Yes, it is. Now I also have all of this, which is like some table data, which I've never been entirely sure what I want to do with. Yeah, it says right there I wanted to store that in a context for some reason. Presumably so that I could support more than one, like, C++ version at some point in the future, maybe. Don't know. I'm not going to put that on the left-hand side, I don't think. I mean, it's going to be a pain in the butt to recreate all of that data, but ultimately what I should do is turn this into metadata and generate whatever all of this stuff is. Yeah, that would be shorter on metadata. All of this would be shorter on metadata. Alright, so now the new Lexer, we're going to call this new Lexer for now, will look like this, and it doesn't need anything anymore. Okay, so first I'm going to include for CPP Lexer types.h. Alright, and then I want to this is all about how we declare stringless submatch list result. That's actually all going to go back into Lexer.h because this all has to do with the table data anyway. Okay, so now the next big thing to do is to break everything, and the way I'm going to do that is by saying for add CPP. Well, no, let's look at app target. I believe this is a spot where, yes. So here I want to use the new Lexer, which is in test. And I want to check the other spots, see if anyone else is using the Lexer. You're not using the Lexer. Lexer, you're not using the Lexer. Okay. So that should break lots of stuff. Great. That's good. And that way, I can start tracking down where I have disagreements between these two things and start making them match. And then what I'll do is I'll test correctness by adding into the experiment part a test between the output of the two of them. So the first thing I'm missing is wait, who's including Lexer.h? Experiment CPP, missing semicolon before submatch list. That's not even the right submatch list result. I see. All right. Okay, so the new Lexer needs to go back one directory to find the types. Okay, so now we just need to implement the missing functions. I don't need to implement anything except for the missing functions, which is good. It looks like there's not very many of them. So get token I can do pretty easily. So let's get that one. Let's get that one just moved over. So that one I don't need to change. Get token. I'm not doing that yet. Okay. So here we're going to just drop this in, and I'm going to reconsider that. I'll probably just throw it at the top of the file for now. So this is going to be FCPP Lexer linking, and I'm just going to say for now that means static, and that's something we'll put more thought into in the future. Or actually, I want these to use this naming scheme now, I think. No, that makes it look like a type. Oops, put you in there. Boop. Lexer link. There we go. I like that. Okay, so what goes on in this code? Well, first of all, I want to rewrite it a little bit to match how I would write it if I was writing it today. So int first, int last. Also, result can go right up here. First, last, and token can go right here. So I take in a token stack, I ask for a certain position. If token stack count is greater than 0, we do some work. Otherwise, we return token index equals -1 in white space yes. Okay, that makes sense. If we're going into the loop, we do a for loop that's going to go on forever. And we have two cases where that might break. And those cases are if first equals last, or if this start is less than or equal to position, and position is less. Okay, where is this start? Okay, there we go. Int this start, next start. Alright. This start is what you get when you take the current token index and grab its start value. Now, how many times do I do token stack tokens? I don't like that. So what I'm going to do is token array equals token stack tokens, token array, token array, token array, token array. Alright, so that's a little nicer. What else do I want to change? I don't like the fact that I'm pulling count out up here and then not actually like taking advantage of that. So I'm going to return all of these into just count. Token stack. There we go. Now finally, I do this nonsense here where I get the token array result.token index up here. I refer to it in those two places, and then next start I go to the next token there. Result.token index. What happens down there? Result.token index. I set the token index here. I don't think I change it anywhere. Here I'm like looking at something that's about the token index, so I could use a token pointer for those. I could use, that's fine, that's fine, that's fine. That would be fine. Here's where I actually change the token pointer, right, if token start plus token size is less than. Right, so I think what I want to do is actually get the token pointer right there. And then this right here refers to the token start. This right here refers to the token plus 1 start. This right here refers to the token size. And then here we update last and first. We update result to token index. And we break. That means we're done and we found what we were looking for. If result of token index equals count, we subtract 1 and we're in white space. Token is then result dot in white space. And then what? Then we continue the loop more? Why? No, this is after the loop. Alright, so basically when we come out, we decide whether or not we're in white space, and these are the conditions where we're in white space and need to do stuff about it. Fair enough. Bad fly dog. No, token array would not be a pointer because my token array is not pointers to pointers. It's not an array of pointers. It's an array of tokens. The tokens are laid out contiguously in memory. They're not. I don't want double addressing my tokens there. Right. I'm not indexing into the array to get a token pointer. I'm indexing into the array to get the token data. So a token pointer is something that kind of walks across the array. I'll make sure everything is initialized now, which is a nice feature of not using declare anywhere. And out the other end, we can return the result struct. So there we go. And that should constitute a better version where we have getToken. Awesome. Yeah, Q or Caleb, I like to create the array of tokens and then parse rather than trying to do both simultaneously. And there's a lot of good reasons for that. For one thing, it's kind of like when you're doing graphics programming or something. If you have a big piece of data, right, and you try to shove that data through a pipeline, if you do one piece of data and you push that through each part of the pipeline, right, I take the first pixel and I do every step of that pixel, then I take the next pixel and I do every step of that pixel. I'm losing out on cache stuff because my pixel is probably going to have to visit several spots in memory to finish that one pixel. And I'm also losing out on iCache because I'm probably doing a lot of different jobs on that one pixel. So it's easier on the cache often if you take your big piece of data and do the first step on everything at once. Then you get to get cache benefits for iterating across the array, and you can keep your code in a smaller, tighter area so that you don't have as much trouble with you know, like branching and iCache misses and stuff like that. So from a hardcore optimization point of view, making things faster is often about doing the same job on the whole bunch of stuff at once. Plus, like you said, it threads nicer when you can do a pipeline this way. So yeah, I have a system where if you want to run the parser, you need an array of tokens. And the array of tokens can be generated incrementally. Well, it will be able to once we get the new one ready. It can't be done yet very easily. Like you can sort of like say, okay, stop, that's enough. But you don't have very fine-tuned control over why you're stopping. You just choose to stop after X iterations. Yes, you do use more memory to let the token sit around. But who cares? Memory, like having used memory isn't usually bad. It's the only thing you don't want. Like when you're optimizing memory, it's usually more of a problem if you do like, oh, I made my structures really wide so that they don't fit into the cache line or something like this. That's a problem for memory optimization. But if you're just saying like, oh, I don't want to have more arrays sitting around for metadata that speed up the thing, that's not usually the right trade-off to make, I don't think. And especially not here where you can get a lot of benefits out of the lexing, because the lexing is really just the most time-consuming part of a parser, according to Sean Barrett's article on Lexers. So caching the result and then only incrementally, so that if I make a change to the file, I only have to incrementally update my tokens rather than re-lexing all the time, like for every frame or every time I'm re-rendering or something. It just makes a lot more sense to me to do it that way. For all those reasons. Okay, so now what we need to do is look at these things. These are the more interesting things. Well, first of all, these still might be easier, so let's take a look at those two. Get end token. Okay, lexer.h. Get end token is apparently important. What does get end token do? I can't read it. Wait, get a token. Okay, so that's this one. I say here's my end. It gets the token. If the token index is less than 0, the token index becomes 0. Else, what am I returning here? I'm returning a token index. Else, if end is greater than get end token. End. I remember doing this nonsense at one point. End stack tokens token index dot start. So I look and see is end greater than start. The start of the token. I can't remember where I'm using this. Let me look at compilation. What is this doing? It's in file view 813. What does get end token do? End token I. First file lex parallel. End token I. I feel like this shouldn't actually be a function because I'm using it in one spot and it's a fairly specific it's like it's too specific to be what's the word I'm looking for? It's too specific to be like a function in this area because it's really just about what's happening in this one specific spot in the code. So instead what I should do is I should transplant this code from over there. So here's how we do it. We make sure that all the local variables are going to line up, renaming anything we need to. In this case, we've had to rename both of our parameters. Then we say whose our result is end token I. Come over here, we grab a copy of the function body. That becomes just this thing in these quotes here. And this is kind of something I talked about in that blog post I made. The way I tend to fix code around is I make something redundant first. So I had this function over here, but then what I've done now is I've said, look, there's only one instance of the function now, so it's redundant, and that's how you eliminate a function from your code, is you just get all the uses of it down to one spot, and then you can literally transplant that into the same thing without that thing existing, right? You can just move to having the same exact system, but without the function being there. And then you just massage the code to get rid of the awkwardness that's caused by these mechanical transitions that, you know, don't exactly reflect how you would write it in these situations. Sigh, Fucon. Who knows? That's terrible news that you've got a bug that you were crashing on yesterday that's not crashing on you today. It's very frustrating when that stuff happens. Okay. So there we get end token I. File relex parallel. Whoops, didn't save that. Doo-doo. Okay, so now we don't need to write end token. Let me just take a little bit of time to make sure that this has been properly worked. So this can just be the stack, because we're going to use the stack pointer in a few spots. Again, this is just the stack. Okay. end equals end I. So end is just end I now, because we're not editing it anywhere, so we don't need a copy really. And now these braces are redundant unless I have something that's called result. No, I don't. Okay. Now, finally, result. Whoops. What do I use? What do I use result for? Just for the token index. So what I should do is say that actually what happens is we get this, and when we do I32 end token I, CPP get token. So this will be end get token result, because we only need to refer to it in one spot. No point in having short names, not in my style. And then result.token index can just be replaced with end token I, so you deal with it directly. That seems good. Okay. There we go. Now what? Let's get to these other functions. So I think shift token starts. That's only happening in one spot, but it might be one that makes sense to have more than once. 820 shift token starts. That one actually does sort of conceptually still, even though it is totally collapsible, I don't feel like it's confusing to me what that does. So this one is just gone, but shift token starts we're still using. How does this one work? I get count, I get a token start plus equals amount. So yeah, you basically say starting from this token, shift by this amount, and you just walk across each token adding that much to its start value. Alright, so okay, so there's only 3 functions left. And the main one is going to be CPP lex file non-alloc. Okay, so that's where the interesting stuff is really going to. Well, let me do one other thing. I haven't actually done this yet. From token I. Why don't I just do? There is no I variable. Well, it never hurts to have an I variable. From token I. We're going to make you that. We're going to put you right there. Now, you're a short one. I'll put you there. Token equals tokens plus from token I. Plus each token plus the shift amount. Looks good. Spelling errors. What? Spelling errors? No such thing. Me? Spelling errors? Never. Okay. So, let's deal with this CPP lex non-alloc situation. Compilation. CPP lex file non-alloc. So I have relex non-alloc and lex file non-alloc. That's bad naming, Alan. Bad naming. So what we're gonna do is we're gonna visit the spots where I call that first. 663 lex non-alloc. 669 lex non-alloc. Okay. Now it's going to complain about those functions not existing, which is fine because it's correct. They don't exist yet. And now lex file non-alloc. Okay, so this is where we're going to start to deviate from the way other things work, because this right here has got like pushing a token on the list, and it's going across all the data, and it doesn't really work in chunks. So this is where it's time for us to shine and come up with our own rules. Lexer link is the thing I need here. And this is CPP lex data, and CPP lex non-alloc, CPP file, CPP token stack out, CPP lex data. Alright. Now, the thing that's going to change is I don't want this CPP file thing anymore. It's dumb. It's super dumb. So we're going to go over here to types.h. No, we're going to keep it. We're just going to say, if you're on the smart side over here, then you just get a chunk and a size with that chunk. Okay. Cuber Caleb is a stack because you push things onto it, and you know it's not exactly like you pop things off the front of a stream of tokens. Now is it? Actually, the main reason it's a stack was because I was really into naming my growable array stacks for a little while, and then it became useful because there's this concept that when you push something onto the token stack, it can merge with the thing that's already on top of the token stack. So it kind of is a useful concept to think of it as a stack instead of just an array for me. And so that's what I do. Now, CPP lex non-alloc. Well, Keeper, you don't really pop either end. Once it's there, you just read it. I just call it a stack because you push onto it like it's a stack. And when you're building things up, you always care about what the last thing was. You always peek at the top while you're building the thing. So no, it's not strictly a stack. It's just the way my mind wants to wrap my head around it. Fucon, you cannot pass buffer seek delimiter more than one delimiter. It is a flaw in the delimiter seeking situation. And that is all there is to that. Fucon asks, what does non-alloc mean? And I have to restate that because he does not ask what non-alloc means. The one who does ask what non-alloc means is Connor Rentz. So Connor Rentz, the reason that there's a non-alloc version is because the alloc version, this is actually from the old system. I was trying to be fancy. I had like the non-alloc version, and in 4coder I only use as you can see here, I only use the non-alloc versions of anything because I have my own memory system. But I wanted to provide, because this will someday be a public library, I was thinking ahead, and I was like, well, I want to provide a version that just relies on CRT. So the versions that don't say non-alloc will automatically malloc things for you and run to completion, whereas these will say, hey, I ran out of memory if they run out of memory, and then you can manually resume them with more memory if you need to. T-Melemster, I'm sorry, I don't know what those letters sound like together, but yeah, my semaphore thing is kind of, I understand the issue now. My solution is mostly correct, like I deserve more points than I got, and I'll be able to argue that. But I did have a misunderstanding about semaphores, which contributed to the confusion a little bit, which is that semaphores are one-sided. I always thought that a semaphore, like you set a max and a min value, and then if you tried to increment or decrement outside of that range, that you wait until until like somebody else moves it the other direction. So that if you try to move below 0, you wait, and that's true. But I also thought if you tried to move above the max, you wait until someone moves it down. I don't know where I got that idea, but it's like everyone in the world agrees that that's not how they work, and that you're not supposed to increment them past their max, and that's just a bug. So there's a slight wrongness there, and I would have to flip the semantics of the backdoor, and that would mean I would want to change the whole visualization. But if two-sided semaphores were the actual situation, I would have been exactly correct. Okay, so anyway, the way this thing worked, as I was saying, was that you would provide the Lex data, which could initially, you would just make a struct clear to 0, and then what would happen is if it ran out of memory, which it would indicate by this function failing, it would then stop the lexing process and halt. So what I want to do is I want to, and I haven't looked at it for a while, but I want to start building from scratch a new lex non-alloc. But first, I think what I'll do is I'll just simulate this behavior here. Complete equals 1, whoops, return data. Alright, so that will just basically mean you put in a chunk, and then it parses it, and it determines that there are no tokens in your chunk every time, and then it says the job is complete and it returns. Now what I want to do is I want to switch over to experiment. I'm in the mood for some like proper hardcore engineering, and since I have a pretty solid Lexer already built, I figure why not set up some nice test cases where I can you know, test this thing like for correctness against a bunch of files. So we're going to work on that. Struct data char star data int size. We're going to just rely right on Windows so that I can do this in a really cool way. Why I always feel the need to capitalize Windows there is kind of weird. Data, static data dump file, char star file name, bye bye again, handle file equals create file, and here I'm going to have to put the brakes on and look at create file. Okay, so roughly speaking, if I pull experiment up over here and I put that right there, I can grab a copy and paste, and there we go. So we can put you back over there for now. And now, let's see, yeah, so it's file equals create file. We already did that part. File name. DW desired access. It says, I want generic read in this case. Generic read. Share mode. The requested sharing mode of the file or device which can be read. 0 I want. Okay. So there's file name, desired access, share mode, security attributes. I believe that's usually just null. Security attributes, creation disposition. That can probably just pop up here. Creation disposition. Open existing. flags and attributes. The file or device attributes and flags. File attribute normal being the most common default value for this file. Okay. File attribute normal. Template file, I believe that is usually null, if I recall correctly. Template file, this parameter can be null. A valid handles which a template file with the generic read access. Right, the template file supplies attributes and extended attributes for the file that is being created. Okay, we're not creating a file. So there we go. Down here I'll close a handle, and then we'll do look if file does not equal, and then I believe it's invalid handle value. Okay. Now here's data. What do we got over here? I've got it's not in my chat. I see. Miblo is coming to join. That's what the notification was. That's good to know. Good to have Miblo coming to join. So now what's going to happen is if we create the file, and then I want to be able to do like file read type things. Like, do I have see also down here about that? Create file, delete file, read file. Reads data from the specified file or input-output device. Reads the correct position specified by the file pointer if supported by the device. This function is designed for both synchronous and asynchronous operations. For similar function designed solely for asynchronous operations, see read file X. No, just want synchronous, please. I will do everything synchronously, please. If you don't mind very much. Let's see. A pointer to the buffer that receives the data from a file. This buffer must remain valid for the duration of the read operation. The caller must not use this buffer until the read operation is the maximum number of bytes to read. A pointer to the variable that receives the number of bytes read when using a synchronous H file. Read file sets this value to 0 before doing any work or error checking. Use null for this parameter if it is an asynchronous operation to avoid potentially erroneous results. LP overlapped, that'll get set to null. So buffer size output, and overlap. Now how do I get the read file function returns one when one of the following conditions occur? The number of bytes requested is read. A write operation completes on the right end of the pipe. An asynchronous handle is being used, and the read is occurring asynchronously, and an error occurs. No, none of that. I want to know how I get, well, system load file. How do I get the size of these things? Blah, get file size. Okay, so I have to do that separately first. So data.size equals, well, I can't even do that. First I have to do get file size on file, put my high right here, put my low right there. Those are D words, high and low. I would like to say we're going to assert that high equals 0. I don't want giant files going on right now. Low, that's what I'm going to put in here. Then I'm going to say data equals malloc data size plus 1 char star. Then I'm going to read low bytes into data. I'm not going to ask for, let's put this into low again. And then I'd like to assert that low equals, or that assert that int low equals data size. Doesn't need to be super robust over here. We're just we're just setting up a test situation. 79. Looks like some kind of British spelling of the word stack got in there, or something. Experiment, please. There we go. What's wrong here? Data structure type redefinition. Really? Okay, so I already have that defined in meta, I think. Why, Keeper Caleb, why would I use get file size x? That would make no difference for my purpose. Cannot convert from char star to byte. Fair enough. If we're going to use that system, here we go. Read file. Cannot convert argument 2 from dword. Okay, so it's buffer first, then size, I think. Yeah, but my point is I don't want larger file sizes anyway. I'm not dealing with larger files. I know the size of my files. Does not take 2 arguments. Lex non-analog does not take 3 arguments. Correct. It takes neither of those amounts, and that's fine. New. Okay, so there we go. Now I have the ability to dump a file. The other thing I'm going to want the ability to do is to do a file list. So this I'm going to just pull right out of here too. Set file list. The code looks something like this. In the other case, dump file doesn't quite the way this one works, but this one is just perfect. I can just copy it over. Then I come over here to my system.h. I get my file list. What is the signature here? Set file list is just going to do static void file list string directory. And then I just need forehead.h for the file list. Where on earth is my file list? System.h. There's no file list here. Does it get defined later in this file? No. Forehead.h. Oh, is this in types? File list? No. How about custom.h? File list? There it is. Alright, so that was a bit of an adventure, finding the right thing there. Hopefully, I think that will just transplant pretty nicely. And then what'll happen is I'll do like char star. No. So then what we'll do is we'll say here's my directory, the test directory, and it will be w/file fored data test slash, right? And don't ever forget that the slashes are stupid, and you must not use Windows slashes because they're stupid. Okay, so now what we can do is say that we have a file list, files, we'll call this all files, and then what we'll do is system set file list all files make lit string test directory, and now it will come in here, give me all the files that I need. It's going to use Win32 free memory and Win32 get memory. That's fine. We can define those two. Void star Win32 get memory. Int size is just going to go like this. Return malloc size. And Win32 free memory in this case. Just going to take a void pointer. Putter. Doesn't have a return, and it's just going to free that putter. So, how is the experiment going? Yeah, I could use \\/ to escape the backslash, but as I've learned recently, everyone just wishes that backslashes weren't ever used in file directories, so you're always just going to want to use the /. Just take my word for it. Following the Windows rule there doesn't make any sense because Windows basically always respects /s in pretty much all APIs in all cases anyway. So you might as well, since it makes things like more standard, just always / things. We are missing file info, you're right. So let me grab custom H and find my file info struct. There it is. Whoops, built on the wrong one. If you could please now have him and you have experiment. There we go. Recompile module. What are you talking about? What are you talking about? Okay, what is this talking about? I'm looking for things called experiment. You're all dead to me. What are you talking about? That's insanity. No, not pictures. W. Fored. Build. Okay, so experiment. Experiment. Gotcha. Gotcha. Okay. Now that's better. So now it's getting me a file list, and then what I want to do is for I = 0, I is less than all files, count ++I. Then what I can do is look over here at my custom H where I have a file info thing, and the first thing I want to do is say, look, if all files.infos_I.folder = 0, then I'm interested in this file. And what I'd like to do with this file is I'd like to let's see, basically we're going to say printf testing on file blah with blah being all files infos I dot file name stir, and then I would like to end off with test finished, new line, and in betwixt those things, I would like to dump all that data. File data equals dump file. Dump file, and then right, at which point I will invoke the Lexers. So, Lexers, here's what's going to happen with you. We're going to need 2 token stacks. CPP token stack. Wow. That's insanity. That's properly insane. Okay. Okay. So token stack, we're going to call this the correct stack and the testing stack, right? So one of the stacks is assumed to be correct and the other one is assumed that it is assumed that we are testing that stack because we have chosen to test that stack. So really it's not an assumption. Really it's just a thing that we know because we made that true. We made that thing's fact a true fact so that we would just be able to know it. The other one we're assuming because it's a statement about correctness, which is harder to ever really know for sure, you know? Okay, so I need to look at types.h of the Lexer types, and I need to see the stack. Why did you open up? You should have given me the same thing twice. Damn bastard. Okay. Gotta get that file. We got this thing in the works that'll prevent files of name clashing, blah 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 blah, but it's not ready yet. It will fix soon. Permanently across all platforms very soon. FCPP, huh? Don't really love that. Gonna eliminate that soon. But first, since it's all over the old one, we'll stick to it for now. Don't like these types. For now, stack, there it is. Token stack tokens equals CPP token malloc size of CPP token times. Okay, I just want to make sure I'm going to always have enough tokens here. So, or you know what, if we don't have enough, we're just comparing the first amount of tokens we were able to fill up anyway. So they're both going to have the same number, which is going to be token max, and we're just going to leave it at that. Correct stack, testing stack, and really what we want to do here is make a void, static void init test stack, CPP token stack, blah blah blah. There we go. Grab a copy of you, stack. There we go. I can define right here token max to be something on the order of 1 bit shifted by 12. There we go. Token max, there we go. And then I can do init test stack, correct stack, testing stack. Okay, so that gets both of those set up. Yes. And then what I'll do is on each run here, I'm going to start by taking the stack, setting its count to 0 again. And by taking the stack, I mean each stack individually. Correct stack.count. Testing stack.count. And then we're going to clear them to 0 just to be sure. Correct stack dot tokens token array size equals token max times the size of CPP token. There we go. There we go. So now we're clearing everything to 0, so they're all back to beginning. Their beginning states. And then we can finally invoke our Lexer. And we will say to our Lexer, "Dear Lexer, why don't you go cpp lex file non-alloc yourself?" As I said, I think this system is stupid now, but the old system still relies on it. File data Lexer Lexer types. CPP file data equals char star data file cpp dot size equals data size. There we go. Then I can pass in file cpp. I can pop over here, get rid of this because why the hell is there another copy of that file open again? Give it a pointer to the correct stack. Give it a empty thingy do, which I should really do it this way to get in the practice of doing this correctly. CPP lex data. We'll just clear you to 0 to begin with. Alright. And then down here, lex data. Okay. So that runs the non-alloc job using the old Lexer. Got some comp errors going on here. Right, so there's nothing called data, so I'm thinking of file data. Ooh. Okay, so that works. And now what I want to be able to do, well, first of all, let's stop right here because I want to see if I can run this and catch anything weird going on there. So bear with me here while I remember how to run the experiment. Run exp, it looks like. So run exp. Okay. Bear with me for a little bit longer while I go and beat the batch out of this file. 1 minute. So that's buffer test. What about experiment? Okay, so this actually runs the experiment. So it's experiment. Aha. So now what I would like to do is cd to the build directory. Wait, do I have debug for experiment? I should have debug for experiment. Debug exp. Ah, I do. So that shouldn't really be called this, should it? This should be called debug experiment.bat. Save as doesn't work. Okay, meant to hit F2. I'm sorry. Experiment. There we go. What do we got going on over here? Connor, rents. Nope, I did not add the saving of themes. That did not happen. I added the ability to make themes on the API so that if you have the API, you can do that. Someday I'll add saving of themes. At one point I had saving of themes, but right now we do not have saving of themes, and I did not re-add saving of themes. In fact, I just totally disabled it so that it wouldn't cause crashes, is what I did. Okay. Franti chat, I can help you out there. The way to do, the way to debug an exe on Visual Studio is to have your executable file in the current directory and run devenv. Run devenv is the debugger. Put the exe as the command line parameter, and you might have to do this after running the clvars thing or vars.bat, something like that. You can watch the handmade hero part for how to run the vars batch, because I try not to mess with that because it is insanity. Okay, debug experiment. Yeah, Connor, he does. That's my point. Casey has his theme. His custom file is set up to load his theme. Right, so what happens is if you have the API code, you can write a little command that says change theme on the start hook that changes theme to one of the existing themes, and then you can customize the colors to your liking from there using change color, which is another function that lets you change individual colors at a time. So that's how like the what's it called? The blah, 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 blah. The thing works. The toggling modes is using the color changer, and he's automatically setting it. So it's not saving the files, or it's not saving new themes, and it's not saving which theme you want to load. Neither of those is happening. Tharzik, this isn't about modifying how C4coder parses. This is about improving the internal parser of 4coder, so that I can get to the parser. There's not really an API for parsing beyond just you grab a snapshot of the whole file and parse it, which you're allowed to do. Which we don't have yet is the ability to do anything with that, like colors and stuff. You can't manually color anything, which will be in there someday, hopefully, probably, maybe. But that's not at all what I'm dealing with. Right now, I'm just working on setting up a new experiment test situation so that I can start working on the new Lexer. And we're running out of time. I was hoping I'd do a little bit of metaprogramming because I want to auto-generate these files, but I think I'll put that off until I've rewritten the Lexer at this point, because it looks like I'd rather do Lexer first and then write the auto-generator. Gotcha. So what I need to do is I need to clear this to 0. And while I'm at it, I'll clear everything to 0 because everything is better when you initialize things. Life is better when you initialize variables. Do 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 do. There we go. So that just ran. I don't want it to run on things that don't end in CPP or H. So I need to test the file name. But other than that, we're looking pretty good. So before we test it on a particular file, I would like to get a let's see, let's store a string up here, extension, clear it, up here, right here, extension equals get file string dot h extension file extension from all files infos I dot file name. Right, and once you've got that, what you can do is say, look, if match extension CPP or match extension H, do everything else. Aye. Experiment. There we go. So we got those other non-C++ things out of the way. So you can see we're now running the test on everything. The problem is there's nothing to test yet. All of these files are the same because, well, the files aren't the same, but all of the tests are not failing because there's no test. There's no test code in here yet. I'm just parsing it with the correct parser. DGMTV, I don't understand your question. There's no colors in the text buffer, but colors aren't in any buffer. So I'm not sure what you're asking. Colors are basically ranges. And right now, the only way that ranges come from are from the tokens. So if you have an array of tokens, it gets its ranges from each token. But it is like halfway in there that you can add an array of other ranges. And as the colors, or as the file is edited, those ranges are kept correct, so that they refer to the same words that they always did, and then it colors the things. Yes, agreed. We need better font support, for sure. That's just busy work. I mean, I feel like I could do it, but I don't feel like doing busy work right now. I gotta do some experimental stuff for a little while to get my, to get it off. And I think next time I do UI level stuff, we're gonna finally crack the font problem open and deal with it. Okay, so next up, what I need to do is pop over to the new Lex, where I have CPP Lex non-alloc, and that's going to be under new Lex CPP Lex non-alloc. Here is the chunk, which is just char star of file data and file data size. Here is the testing stack, and again Lex data. And then what I would like to do is say if correct stack dot size does not equal testing stack dot size, printf, and what I'm gonna need here is like pass equals 0, and at the beginning of each of these things, what I'll do is I'll say, look, here we go, pass equals 1, and then if something goes wrong, pass equals 0, error, stack size mismatch, original and testing, correct stack dot size, testing stack dot size. Alright, so that should just give us errors on everything, and then right at the end I would like to do if pass printf test passed semicolon or exclamation point, else I'd like to printf a different message, which is test failed, you failed, fix it now. There we go. That's good. Size. Is it count? It's count. It's count. I lied. It's not size. There's no size. It's count. There we go. Okay. And then what I would like to do is say for j equals 0, j is less than, we'll do int j in here, j equals 0, j is less than min count plus j. And what will happen here is that min count will be correct stack dot count, and if that is greater than testing stack dot count, then min count will equal testing stack dot count. And then what will happen is for each of these we'll go, look, here's the correct token and the testing token. The correct token comes from correct stack dot tokens plus j. The testing token comes from testing stack dot tokens plus j. If correct, and I need to go over here and look at Lexer types. Token. If correct token type does not equal testing type, printf type mismatch at token %d blah 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 j, pass equals 0, start size. I'm gonna ignore the flags because the flags are the state flags, but everything else I'm gonna test. So type, if start does not equal start, or if size does not equal size, token range mismatch, and then I will do original at token So there's your token. Here's your token start. Here's your correct start. Here's your correct size. Here's your correct size. Here's your testing start. Here's your testing size. And do do percent dot star s original percent dot star s testing, and those will just be a matter of correct size, comma, correct start, plus file CPP data, boom, 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 actually, correct, testing. Yeah, Rooster441. I want him to put the Handmade Hero customizations that I have at the power tier in his thing for Handmade Hero people, because I feel like he worked on that on Handmade Hero, and people following along on Handmade Hero have always had access to his customizations in the past, and he wrote it, so I don't really feel like I want to tell him he can't put it in there. For people who bought Handmade Hero, it feels to me like they should get the benefit that if they happen to have 4coder, Super, and Handmade Hero, that's good enough to get the Handmade Hero customizations too. Like, because that wasn't like entirely mine, so I still don't know if he put it in there. I haven't checked, but perfect. So, god damn it, I did it again. Why the fuck is that open twice? Go out, get out of here. I don't want to see you around here anymore. Types.h. I swear, there's something off. It must be that I loaded it with a little w or something. I don't know. That error has basically stopped happening, and now it's back. Alright, if he didn't put it in there, I'll tell him again today to start putting his customizations in there. Alright, so let's take a look. Now when I run an experiment, I should get a bunch of "you failed, fix it now." Stack size mismatch. Yeah, so basically we have a bunch of stack sizes that are mismatching, and that's because the new one doesn't do anything. So let's get started now. Now I have a proper test case, and until I pass every test, what I want is like int passed all equals 1. And right here, passed all equals 0. And at the very end, we'll put a printf. If I passed them all, we don't really need this anymore. We just need to make sure that these all have the double new line. If passed all test, passed all, da-da, da-da. Oh, this should go in there. If passed all, and the message will be something like, "You passed all the tests, congratulations." And this one will be like, "You failed at least once, and that's all it takes to be a loser." Okay. Perfect. Awesome. So now with the proper motivation set up, let's get all of these things matching. Here we go. So, new Lexer. This right here is going to be pretty tricky. Because the old one is written in a style that I don't necessarily want to repeat, but it had some merit, so I have to be thoughtful. First of all, CPP Lex step. This is where all the work happens, and basically the way the Lex step works is it first of all looks at a current state situation, we ignore white space, and then we look at the state. If we're doing default stuff, we do that with the preprocessor, and otherwise we do other preprocessor stuff. So this is all basically handling preprocessor stuff, and then right here, if it's white space, we consume it. PPP default, PPP, right, then what we do is we look and see if we're starting a preprocessor, and if not, we do regular stuff. So, what I want to do is try to not separate this out so much right away, at least. Hopefully not at all, ever, maybe. It's hard to say. Without making it steps, we can't make it a resumable Lexer as easily. But, that's not to say we can't make it, at least in some small, interesting way, resumable. But, file non-alloc, file lex file token can't. Okay. So, CPP lex data. That provides a position. What else does it provide? I need to go to my types. I need to switch to it instead of opening it, or I'll get the thing that drives me crazy. Lex data gives me a preprocessor state, a position, and a completeness thing. So I think what I want to do is say that we're going to assume we don't have one of these for now. And what we're going to just do instead is return an int, which is our result, that tells us whether or not we completed. And then in the experiment, I just have to update to not passing in lex data here. Okay, experiment. Okay, experiment. Now, new Lexer. Now, the interesting thing is how I'm going to structure this. So I have to think for a while. I should null terminate it, for one thing, if I want to make it as high power as possible. Experiment. So we'll say these things need to be null terminated now, which I believe was a part of my initial plan. So dump file, I believe, null terminates my chunks, and we'll say all of our chunks are going to be null terminated in this system. Hard to say. Do I want to null terminate it? No, that's going to cause me too many problems. Like, there's like some hyper optimization stuff that maybe I can do someday where I'll force myself to null terminate, but we're going to write it without that. So no null termination, which means we're going to need a loop. that's going to start at position 0. Now what I also need to actually provide here is start offset kind of concept, which goes like this. This is always fun for me to write. Chunk is the beginning of some chunk. I need to subtract start offset from that, so that when I add start offset in, I get and see if I can then translate that later doing metaprogramming into a state machine. Okay, so the hard part is getting some of these rules correct. So for instance, let me just open up one of my test files here and start looking at what I need to do. So AutoTab, that'll be my first test file. Data test AutoTab. So comment will be the first thing I try to do. So basically what will happen is I have an int called state, right? And it's going to initially be 0. And what will happen is I'll switch on the state, and then after that, each of those, right, so state 0, here it is, here's state 0, I switch on the chunk position, right, and then I do things in here. So for instance, if I see this, I'll go to state equals 1, whoops, state equals 1, break. And this will start off being horribly non-efficient, but we'll get there, right? So case 1, break, switch, chunk, position, boom, case, boom. Now I'm in comment mode. So what I really need to do is introduce an enum that describes all of these. So parse, or we'll call this lex state, starting with ls default, ls comment pre, ls comment. So this is going to ls comment pre. This right here is ls default. It initializes to ls default. This right here is ls comment pre. This right here takes us to ls comment. Let's see, this right here takes us to ls comment block. Okay. Alright, so now, let's see, what's the case here? ls comment will basically go until if chunk position equals end of line, right? If we get to the end of a line, that ends a normal comment. So then, if we're at the end of a line, then state equals ls default. And we also need a method of emitting tokens as we go. So what I'm going to do for that is say, let's look at this, breaking this output token stack a little bit. CPP, let's break it down. Out tokens equals token stack out tokens, int token I equals token stack out count. At the very end, what I'll do is I'll say token stack out count equals token I. And whenever I emit a token, what I'll do is I'll say out tokens token I equals, and then I need to fill out a token right here. And so then what I need to have is I need to have a CPP token that I'm perpetually building, and I'll clear it to 0, and then what will happen is things like when I see this, I'll say the token dot start equals position. When I see this or this, I'll do token dot type equals CPP token comment. Alright, so that gets me a state, or a token type. When I get here, going to get token type equal, or token size equals token end, position minus token start. And let's see if there's anything else I'm forgetting about. Types.h, CPP token. What else do you have? Start size. So type start size. State flags. Flags. I don't have any flags for a comment, so I'm not setting any flags right now. And the state flags. So the state flag is basically just where you go, look, here is the state that you want to be in after you have done this, right? So there's your state. It turns out our state needs to be unsigned short, which is fine. I'm okay with that. And then we write out our token, and we do token I++. Then I navigate over to code, and boom. Now it has a problem with that. It does not like something I did, and that's okay. I'll have an argument with it. I'll tell it why it's wrong, or it'll explain to me why I'm wrong, and we'll come to a consensus. For instance, in this case, I'm wrong, because I need to specify that it starts at 0. Alright. Experiment. Alright, I failed at least one. Okay, so let's see here. Token range mismatch at token 0. Testing junk original testing. Right. One length of 0, huh? That's a bit odd, don't you think? That should have worked. What about this first one? Auto tab 29. Crazy should have just worked. Right, so crazy, not junk. Where's crazy? I should be passing crazy. Crazy. Clean me. Crazy words. Interesting. So I think the problem here, Lexer, here's the new Lexer, is that I want this to also have a comment block thing, which says if I see a star, then I'm not ready to put a token out yet, but what I am ready to do is to try comment block ending, and so I'll need another state for that. And there we go, another state for that. Comment block ending. And if I still see a star, I see that. So what I really need here is a switch. If I see chunk position, boom, I want a case of star, which does this work, sending me back to the same state and doing nothing else. And I want a case of close, which does the work of actually finishing a token the way this one up here does. So in that case, we emit a token and go back to the default state. Okay. Experiment. This is crazy town. Uh-oh. I see what went wrong here. Now, before I talk about what went wrong, what? Why are they so many tokens? Oh, we're parsing large? Yeah, so that's what happened right there at the end. Okay. So what we also need to test is that and token I is less than max token I, right? And max token I got passed into us right here, I believe, with something called max count. The other thing I would like to do is I would like to go into experiment now. Experiment. And I would like to say, here what we're doing is we're saying get all the files, and for each file then run the experiment. So what I need to do, basically, is say void run experiment, and we need like a struct of like experiment with all the stuff in it. And so let's see, we'll need, this can just become a global, because who cares? File list, all files, don't care. Correct stack, string extension can become local to in here. Pass, so yes, these guys here are all gonna hang out up here. Do-do-do-do, 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 do-do-do-do. Code transform, could have done that. Here's the experiment data. Here's the file name. Grab a copy of everything in here. My bad, everything in here. Ba-doop, boop, boop, boo-doo-doo-doo-doo-doo-doo-doo-doo-doo-doo-doo. File extension. Here we do a file dump. Actually, just to be sort of nice, I should do a free on that, you know? Just for fun. Just for funsies. So anyway, it comes in here, and we have this exp pointer now, so we get the extension of the file name, and from now on we can just refer to it as file name, which is nice. What happened to, oh wait, we're gonna get the file dump, hasn't happened yet. File name, there we go. Of course everything else is still broken, but what I can do is say in here, run experiment on my experiment data using all files infos I dot file name stir. And then what I can do is say up here, replace all of this with experiment exp, clear it to 0. Set exp.passed all to 1. Badoo. exp dot. Don't care about any of that. All files, run experiment, exp dot. Alright, so now the only errors we should get are all the things where the pointers are missing in front of these names of things. Make strings slowly, first of all. 1999. Alright, now exp pass. Actually, you don't need to be in there. You can be right there. Perfect. That will save a little bit. 203. exp arrow. exp file cpp, file cpp, file cpp, file data, file exp, 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 da 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 exp exp da 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 exp da 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 da. 271 experiment exp. Awesome. So now the nice thing is, if I want to, I can zoom in. I've got this all set up so that I can do multiple tests, but if I want to, whoops, if I want to, I can zoom in and say, hey, how about we just run the experiment on the spot you get when you go to 4ed data test crazywords.cpp loop 259. You're worried about things that aren't important. That's okay. We'll just do some allow locals so that you won't worry about them. Test directory, allow local, all files, da 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 da, experiment, badoop. Token range mismatch at token 0. So the first token we have here wants to range from 0, 926 to, and this one is 0, 0. Right, we're missing that. There's nothing here. Silly. Something's wrong with the Lexer that we've just written for comments. So what is wrong with how I'm computing the size? I'm taking pause. I'm subtracting. Okay, so this is just wrong. That's bogus. This is bogus. Don't write that code. That code is dumb. That code is very dumb. That code is very dumb. Okay. Lexer types. CPP token, state flags. The point of state flags is you've got those extra 2 bytes sitting around. So if you want to be able to do relexing, what you do is you make sure your lexing state can fit within 2 bytes. And then, whenever you need to do a relex, you can just look at the token and see what state you're in the middle of. So you can just relex from any character because you have the state information encoded for the character right before. You just look at the token and go, at the end of this token, well, how is the relexing going? Start from there, use that state. That's the idea. Experiment. Interesting. So what's happening here? We're off by 1 somehow. Okay, for now I'll just push that in. I think that as I collapse everything down in the future that would not be so much of an issue. Awesome. So now there's this cool idea here, which is we have to decide how to not have so much of this code here. And the way to do it is whenever we're going to emit a token every single step. Because for the most part, the rules there aren't that complicated. Token.size equals position minus token start plus 1. Token.stateFlags equals state. Now the only rule is whether or not we update token I at the end. Token I plus equals emit token, right? So then we add right here this sort of variable of int emit token equals 0. And all we have to do is on the spots where we want to emit a token, we set it to equal 1. And what will actually happen is, after every step, we'll set emit token to equal 0. Alright, alright. So now that should be the same as before, except now we just have the one code path for emitting a token. And it's a little closer to how a state machine will work when we don't do it with a switch. Alright, awesome. Awesome. Handmade Heroes in less than an hour. I think I'm going to keep going for a little bit because I'm having enough fun. But I just want to let you all know that we're going to wrap it up before we get too much farther, because we do have to, you know, make sure to catch Handmade Hero. Because I don't really want to miss it, because I never want to miss it ever, because it's awesome. So, now what? Well, one thing that we should do is we're starting to develop this concept of, like, some variables like emit token are supposed to be 0 on every step, and then they get set to 1 by certain processes, and then whatever, so they don't persist. But other things do persist, namely the state and the situation with the token, right? And the situation with the token is that we have a start variable that we are either going to set or not set. And so how do you do that? When you want to mark the start of a token, you're going along. I think what I should do is throw in here this idea of Lex data. Hopefully that's a different name than the other one has. And it's going to have token start in it. And now anytime, that's like me preemptively expecting to have things like this, Lex data. So in the future, what I'm expecting is I'm going to want to be able to resume where I left off after providing more memory, so the Lex data needs to be something that is actually sort of sectioned off. Then we can do completed again, right? And down here, instead of returning all this, we'll go back to returning Lex data, and Lex data.completed equals 1. Okay, so that's back. And token start. So now instead of setting the token directly, what I'd like to do is set the Lex data.token start right here. Right? So where my token start is just always going to be kept in that state. And then to set this up down here, I'll do lex data.token start, token.start equals lex data.start. I think that's supposed to be token start. Lex data token start, lex data token start, state flags. Then we output the token, and if necessary, we emit that token by not overwriting it anymore in the future. Okay, so that's getting there. So what's next? What is next? Let's take a look at experiment again. And let's set it back to running the whole thing. So boop, do 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 do. Happy birthday. Oh, return type. Please return Lex data. Lex data. There we go. Uh-oh. Result. Where's result? Ah, yeah. Yeah. Bye-bye. Ba-doom. If position equals end position, basically. Okay. So now We're all set up to run the full test again, and we should be failing most things still, because why would we not be failing most things? What I should add to experiment is a thing that tells me how many things I'm passing. You pass, so we're not going to do this, or this, or this. You passed blank out of blank tests. EXP passed total, EXP test total. That should give me the error line 280. Oh, 183 was the error line I was looking for. It's passed total, pass or test total. And then what'll happen is in here, each time we actually run a test, we'll take EXP test total and increment it. So, you know, like so. And then at the very end, if we pass, we'll increment the passed total. 264. Okay, don't care about that. 281. XP dots. Badoop. Whoops, that doesn't make any sense. Takes a very long time because of test large, which is okay. A good large test isn't gonna hurt me, nor my feelings, though it might waste my time and should maybe be deleted for that reason. Should maybe be deleted for that reason. One out of 21. All right. So the next thing I want to do is say if it's more than 10 kilobytes, don't run it. You know what? We'll even say 50 kilobytes. You know, 100 kilobytes. That is under run experiment. Once you've done the file dump, only proceed if file data.size is less than 100 kilobytes. And by that I mean 10, which is a kilobyte, 100 of them. There we go. Now I have a file size limit. And so in the future, experiment should not take quite as long. There we go. Awesome, 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 awesome. The other thing I never did was comparing the flags, correct? Flags does not equal testing flags, then pass equals 0, printf token flag mismatch at token %d new line j. There we go. Awesome. Awesome, awesome, awesome. Okay, so now back to the new Lexer. Let's add one more feature before we call it a day. And here's the old Lexer. So I was looking at auto tab. What's the next thing I would have to do? Braces. We can do braces. That's just, there's a bunch of these little guys we can do. So case open brace. If I'm in the default case, that's just always going to be a matter of we leave the state as it is. We do so I'll denote that anyway. We leave the state as it is, and we emit the token. And I need some way of setting token type. I think I overlooked that maybe. No. Okay, so I don't have that in here, but I should. So completed token start into token type. Okay. Badoop. Badoop. So token type comes from Lex data. And then the tokens type should come from lexdata.token type. And then what I can do is whenever I want to emit a token, I just say, look, lexdata.token start equals position. These are all going to be fairly long. Emit the token. So there's the start. Lexdata.token type equals CPP token open CPP token, what's it called here? Types. Give me the Lexer types. CPP token open, no, brace open, there it is. So token brace open, and we emit the token, and that's about it. I think there might be an operator I need or a flag that I need for operators. T flag is operator. So I'm going to ignore that for now because who gives a shit, you know? And then I'm going to just start listing off all these kinds of things, and it's going to make a gigantic amount of code that's going to be unruly and hard to maintain. Bracket open, bracket close. Alright, let's give that a test run. New, god damn it, you go over here, new Lexer 175. Cannot convert from int to CPP token type. Why not? Why can't you do that? It's just so trivial. It's the same bits. Why can't you convert? Jeez, Pete. Okay, so that's no fun. I want to look at experiment, and I want to turn off the doing the full thing real quick, and I want to turn on the doing just one thing. This time it'll be w::for data test, new idea, define baster equal as this thing here, baster, baster, and then I want auto tab.cpp. Experiment. Alright, I'm still failing. Type mismatch at token 3. So I got through, let's see, token range mismatch at token 0. Oh, so we didn't mark any of that white space there at the end as a part of the comment, you're saying? That makes some sense to not do, but it also don't care super muchly. For now, I'm gonna just make it match. So to make it match, I'll just look at the new Lexer and say the size sometimes needs to be smaller. So I'll add in like minus lex data dot size shift, right? And whenever we're emitting a comment, we'll set that to 2. Well, let's do it this way. This will be even better. Size shift equals 2. And then up at the top, we'll do size shift equals 0. There we go. So now the first mismatch is at token 1 because of the flag issue, as I was expecting. So let's add that to the Lex data thing to call it a day. Unsigned short flags, and what I'll do is OBS. Okay. Token flag mismatch at token 1. Huh. Alright, so when I get a token flag mismatch, I want to see it. Flags equals lex data dot flags. Okay. Okay, so parenthesis open is not an operator, apparently. Parenthesis. Okay. Parenthesis open. Right, so when it sees a parenthesis, you're telling me that it doesn't mark that as an operator. But why would it not do that? Op strings. T flag is operator. Op strings. Ops. Yeah, an open parenthesis should definitely have an is operator token. What are you talking about? Is there like a bug in the correct one? That will be really annoying if there is. So correct says, okay, so the reason is that this guy and this guy are now looking at different token types. Gotcha. Fair enough. Okay, so what's going on now? I want to see the actual output. Experiment. So the first thing that happens is a type mismatch at token 3. Awesome. So we've got the first 2 tokens working on this file. Auto tab. The comment and then this brace here. We do not. What we don't have is we don't have anything else working yet. I mean, do we have the first 2 or the first 3 tokens? Ah, we have the first 3 tokens because that's token number 3, the 4th token. Correct. Right. So we have everything up until words working, which is an identifier which we haven't handled yet. So that makes sense that that would not work. So I feel like this all here is going to drive me crazy, even though it's test thing. I'm going to take one more second to do one more thing. We're going to do like, I'll do this even right in there. Define operator case, uppercase, op, type, which just basically looks like this, right? With this being the op, and this right here being the type, and these all being part of the macro, uppercase, code thingy, brace open, brace close, uppercase, square bracket, close. Let's try it this way. Bracket, parenthesis, open, parenthesis, close, close parenthesis, open parenthesis, da-dum. Cool. So now I can do things like now, actually, yeah, that would just be wrong, so I can't do that. I can do token dot. There we go. And so on. So I can fill out all of those single character token types pretty easily. CVP or Lexer. The problem would be, like, if I tried to do plus, for instance, that there's also plus plus. And so anything that and plus equals. So you'd have to parse the next character to know for sure which one you got, which is different from other stuff, which is weird and annoying. But I'll save that for another time. I think this is enough for me today. I take it back. You can't do dot because there's also dot star. Can't do dot. There's also ellipsis. I mean, you can do these guys. Can't do either of these. Can't do. You can do bang. Can't do bang. Can't really. Can you do question mark? Comma. Yeah, you can do both of those. Comma. Oh, hey, Casey. Welcome to the stream. Let's see, what was the other one I noticed I could do? Ternary Q mark. So these ones will work the lazy way. The other ones I'll have to parse ahead, and then I gotta do some nonsense about how to shift everything. Okay, this is it for me, so thanks everybody for hanging out.